in this example, we're going to talk about friction as a force used to slow something down. So what's the acceleration essentially due to friction? And then from that acceleration, we can determine the force. So the first thing I want to do is identify the variables that are given to you in the equation. Here slides a drink across a smooth level bar to a patient at the end of the bar. It has an initial velocity of 1.5 meters per second, and it slides 0.75 meters before it comes to a stop. We want to calculate the magnitude and the direction of the friction force. So we know that the mass is 0.35 kilograms. We know it has an initial velocity of 1.5 meters per second. So we know that it slides 0.75 meters before it comes to a stop, which means that the final velocity is 0. And then from this, we can use kinematics to determine the acceleration. Using the third kinematic equation, we know the final and initial velocities. We know the displacement. From that, we can calculate what the acceleration would be. And so using the third kinematic equation and plugging in what we know, and then we're just going to solve this for A. So we find that the acceleration is equal to negative 1.5 meters per second squared. And now that we know that acceleration and we know the mass, we can use the acceleration of the mass to determine the force that's applied to the glass due to friction, the force that stops the glass as it slides across the bar. So the force is just equal to the mass times the acceleration, which is 0.35 kilograms times negative 1.5 meters per second squared. You get the force of friction acting on the glass is negative 0.525 newtons. Negative just meaning it's in the opposite direction that the glass slides.